Okay, so what we have is a rational equation because we have two rational expressions, x over 2 and x over 3. And we have 12 on the other side. So how do we go about solving such an equation? First step is to combine the two rational expressions together. And we know how we can combine two rational expressions. We can combine them if we have a common denominator. So what is that common denominator? The common denominator here is 6. So we want to get a 6 here and a 6 there. So how do we do it? We multiply the first denominator and numerator by 3. So we will have 3x over 6. The second expression, multiply and divide by 2. We have 2x over 6 equals 12. Denominators are identical, so we add the numerators. Which would equal 12. 3x minus 2x is simply x divided by 6 equals 12. And we want to solve for x. So all we have to do is multiply by 6 on both sides. So 6 times x over 6 would be equal to 12 times 6. Those two would go away, and x would be equal to 72. Okay, so before we try to solve, I'm going to move all the x's, all the terms containing the x's to one side, keep the numbers on the other. So x over 2 plus x over 5 would be equal to 21 over 10. I need a common denominator, and that common denominator is 10. So multiply and divide the first rational expression by 5. So we have 5x divided by 2 times 5, 10. Multiply and divide the second rational expression by 2. So 2 times x divided by 10. And that would equal to 21 over 10. Now that we have a common denominator on the left-hand side, I could combine the numerators. 5x plus 2x would equal 21 over 10. So 7x over 10 would equal to 21 over 10. If we multiply by 10 on both sides, the 10 in the denominator would get cancelled. So 7x would be equal to 21. Divide by 7 on both sides. 21 divided by 7, which is 3. You can always verify your solution by plugging the x back in the problem. So if you take that 3 and plug it in for x here and there and simplify, it should equal to 21 over 10. If you don't get 21 over 10, then your solution is incorrect. So this is a rational equation that sort of looks complicated, but it actually is not. The denominator has an x on both sides. So the very first step is to multiply by x on both sides. Which would mean x multiplied by x squared plus 1 over x would equal x multiplied by 5 over x. The x's simply go away. We'll have x squared plus 1 equals 5. X squared would equal 5 minus 1, which is 4. X would be the square root of 4. The square root of 4 actually means plus or minus 2. So this one, this rational equation looks complicated, but anytime we simply have one expression equals to another, first step to do is try and cancel out common terms. If you look at the problem, we have x plus 3 in common on both sides. So I can just get rid of them. Keep in mind, you can only do that if we have a rational function on the left-hand side of the equation, rational function on the right-hand side of the equation. In other words, you can't have plus 4 or minus 2 and try to get rid of that x plus 3. They have to be by themselves on either side. So if I get rid of the denominators, I simply have x plus 5 equals 2, which would mean x is equal to 2 minus 5. We'll get negative 3. So I do have to make a note, even though negative 3 will satisfy the equation from a function, the perspective of a function, negative 3 will not belong in the domain of the function, because if you take negative 3 and plug it in the denominator, what would we get? We have divide by 0. But in this problem, we're just trying to find the value of x that would satisfy the equation, and that value of x is negative 3. We have a common factor on either side, and they are by themselves. So we get rid of that x minus 1. We have x minus 7 equals 11. Move the 7 to the other side. We have 11 plus 7, or negative 7 to the other side. So x would simply be equal to 18. So here is a slightly more difficult problem. So in the last two problems, I simply got rid of terms because there was one rational function on the left-hand side, one rational function or expression on the right-hand side, and I had a common denominator to get rid of. I can't do that directly here because I have two rational expressions on the left-hand side. The very first step would be to combine them together. So we need to find the LCD on the left-hand side. The LCD of x minus 1 and x plus 1 is simply the product of x minus 1 and x plus 1. And we all know what that would equal to. That is simply x squared minus 1. So to get x squared minus 1 in the first denominator, we have to multiply and divide by x plus 1. So x plus 1 divided by x minus 1 times x plus 1. The second rational function, x minus 1 divided by x plus 1 times x minus 1. The right-hand side is 2 over x squared minus 1. So the LCD, I could write it as x squared minus 1. So I have x plus 1 over x squared minus 1 plus x minus 1 divided by x squared minus 1 equals 2 divided by x squared minus 1. Since I have a common denominator, I can combine the numerators. So I have x plus 1 plus x minus 1, and that would equal to 2 over x squared minus 1. Now I'm at a point where the denominator on the left-hand side is equal to the denominator on the right hand side. So I can simply cancel them out. So I have x plus x, which is 2x. 1 minus 1 is 0. So 2x would simply equal to 2. Divide by 2 on both sides. We will end up getting x to be equal to 1. Okay, so where to start to discover a rational equation? The very first step is to rewrite the denominator 2x squared minus 5x minus 3 as its factors. We need to come up with two numbers so that when we multiply 2 and negative 3, we get negative 6, and we add, we need to get negative 5. The factored version is 2x plus 1 times x minus 3. So if you FOIL, you will get 2x squared minus 5x minus 3 plus 2 over x minus 3 equals negative 1 divided by 2x plus 1. The LCD between those two terms is 2x plus 1 times x minus 3. So I want to turn the second denominator into 2x plus 1 times x minus 3. So I'm going to multiply and divide the second denominator and the numerator by 2x plus 1. Now we have a common denominator on the left-hand side, so we can combine the numerators. X squared minus 23 plus 2 times 2x plus 1 equals negative 1 over 2x plus 1. The numerator would be x squared minus 23 plus 4x plus 2 divided by 2x plus 1 multiplied by x minus 3 equals negative 1 over 2x plus 1. So the 2x plus 1 will go away because I have isolated and have written the right-hand side to be just a single rational expression and the left-hand side to be a single rational expression. So I end up having x squared plus 4x minus 21 divided by x minus 3 equals negative 1. So I am going to multiply by x minus 3 on both sides. So we will have x minus 3, x squared plus 4x minus 21 divided by x minus 3, running out of space. Okay. Okay, so x squared plus 4x minus 21 divided by x minus 3 would equal negative 1. Going to multiply by x minus 3 on both sides. So x minus 3 multiplied by x squared plus 4x minus 21 divided by x minus 3 would equal to -1 multiplied by x minus 3. X minus 3's would go away, and we will have x squared plus 4x minus 21 would equal to minus x plus 3. Move all the terms to one side, so we will end up having x squared plus 4x minus 21 plus x minus 3 equals 0. So x squared plus 5x minus 24 equals 0. Now, so we have to factor that, we have to solve that equation so that we can find the solution. But that equation has x squared plus 5x minus 24 on the left-hand side, which would mean that it has two solutions. So how do we find the two solutions? We have to factor x squared minus 5x, plus 5x minus 24. And what are the two factors? The two factors are x plus 8 and x minus 3. If you FOIL, you will get x squared plus 5x minus 24. From one of the earlier chapters, if the product of two factors is equal to 0, then we can set each of them equal to 0 and solve for x. So x plus 8 is equal to 0. X minus 3 is equal to 0. So there are two possible solutions. One is -8 and the other is +3.
Yes, sir.
So the denominator, the first one, I can factor it and write it as 3x plus 2 times x minus 1. So I want to change the second denominator to look like 3x plus 2 times x minus 1, because the first one so all we have to do now is multiply and divide the second rational expression on the left-hand side by x minus 1. Oh. So we now have a common denominator. The common denominator is 3x plus 2 multiplied by x minus 1. So combine the numerators. 4x squared minus 24x plus 3 times x minus 1 equals -4 over x minus 1. So now I have a rational expression by itself on the left-hand side, and I have another rational expression by itself on the right-hand side. So I can directly cancel things out, if at all possible, which in this case is possible. So the x minus 1 can get cancelled, which would mean I have 4x squared minus 24x, distribute the 3x minus 3 divided by 3x plus 2 equals -4. So we have 4x squared minus 21x minus 3 divided by 3x plus 2 would equal negative 4. Now we're going to multiply both sides by 3x plus 2. So 3x plus 2 multiplied by 4x squared minus 21x minus 3 over 3x plus 2 equal to negative 4 multiplied by 3x plus 2. Those two would go away. We have 4x squared minus 21x minus 3 equals negative 12x, negative 8. I'm distributing the negative 4 in. So 4x squared, move all the terms to one side. Negative 21x minus 3 plus 12x plus 8 equals 0. Combine the x terms, negative 21x plus 12x is negative 9x, 8 minus 3 is positive 5. So we have to come up with two numbers so that when I add the two numbers, I get negative 9. When I multiply, I get the product of 4 and 5, which is positive 20. So the two numbers are negative 5 and negative 9. So I'm going to write the 9 as 5 plus 4. Now distribute the negative. We have 4x squared minus 5x minus 4x plus 5 equals 0. From the first two terms, I could pull x out. So I'll have x multiplied by 4x minus 5. From the last two terms, I could pull a negative 1 out. So I'd have 4x minus 5 equals 0. Now I have 4x minus 5 in common. So if I pull that out, I have 4x minus 5 multiplied by x minus 1 equals 0. So I have two factors, and I multiply two factors. I get 0, which would imply that each of them could equal 0. So 4x minus 5 is equal to 0. X minus 1 is equal to 0. The first factor, if I move the negative 5 to the other side, it would become positive 5. So 4x would equal to 5. Divide by 4 on both sides, x would equal to 5 over 4. In the other factor, it is simply x is equal to 1. So the solutions are x equals 5 over 4 and x equals 1. We did special products for a reason. The moment you look at this problem, but just by looking at the denominators, you should realize, oh, there is a special product here. So I need to first combine the two rational expressions on the left-hand side so that I have one rational expression. So the LCD of 2x plus 3 and 2x minus 3 is simply 2x plus 3 times 2x minus 3. But you've got to recognize that that is a special product, and that is simply 4x squared minus 9. So I'm going to multiply the first rational expression by 2x minus 3 and divide by 2x minus 3. Take the second rational expression, multiply by 2x plus 3 and divide by 2x plus 3. I have a common denominator, and that common denominator is simply 4x squared minus 9. So 3 times 2x minus 3 divided by 4x squared minus 9 minus 2x plus 3 divided by 4x squared minus 9 equals 4 over 4x squared minus 9. Since we have a common denominator, we can combine the numerators. So 4x squared minus 9 would be in the denominator. Distribute the 3. 3 times 2x is 6x. 3 times minus 3 is minus 9. Negative times 2x, negative 2x. Negative 1 times 3, negative 3, would equal to 4 over 4x squared minus 9. Since we have two rational expressions by themselves, we can cancel out the denominator. So those two would go away. And we will have 6x minus 2x, which is 4x. Negative 9, negative 3 is negative 12, equals 4. Move the 12 to the other side. We would have 4x equals 12 plus 4, which is 16. Divide by 4 on both sides. X would be equal to 16 over 4, which is simply 4.